Students, this is Unit 6. Preview note, your last one of the unit, 6.8, rigid transformations. Make sure you get the date, time, location, as well as a parent, a guardian, or teacher sign off. This page is a quick recap of your quad family tree. Go ahead and work this out, then restart the video. Alrighty, students, welcome back. Hopefully you actually did the work on your own, and we're just checking your work here. So we know that opposite angles are congruent. So if this is going to be 5h equals 125, of course, in this case, h equals 25. That's 1. Then we come over here, and we know consecutive angles add up to 180. So if this is 125, this right here is going to be 55. So I have 11j equals 55, and of course j is 5. And this is 55. This is also 55, so I have 7k minus 1 equals 55. 7k equals 56, and of course k equals 8. Coming down here, if it's a rectangle, the most important thing about a rectangle is to realize all 4 of these triangles in the middle are isosceles. If you have 2 equal sides, 2 equal angles. So when it comes to angles, you simply walk around that. That's 53. This is 53. Armpits of the Z. This is 53. This is 53. Take it away from 90. We've got ourselves 37 here. 37, 37, 37. Then you get the middle ones added up to 180. We get 106 here, 106, 84, and 84. All right, that's a quick recap of the quad family tree. Transformations happen when you have movement on a coordinate plane. So a transformation is called movement on a coordinate plane. Movement on a coordinate plane. Your key vocabulary here, something called translation, reflection, rotation. You've seen all of these before. Dilation, K factor, and counterclockwise. There's 2 types of motions on a coordinate plane. Rigid, which means it stays the same shape but moves around. Non-rigid, it actually changes shape, specifically size. So let's just do a quick recap. If we translate something, it means to slide. It stays the exact same shape. It just slides over. Reflection, again, the exact same shape. You just flip it over a reflective line. Rotation, some sort of turning motion going on. So it's turning. That is rotation. All the same sides. Dilation means to change the physical side but stay the same shape. So that's dilation. These are called rigid because the size doesn't change. The size does not change. Whereas non-rigid, the size does change. On the left is today's lesson. On the right is our next lesson. Translation. So I'm going to give you the official equation, and then I'll give you the slang version. If you have an XY and you translate by a horizontal and vertical motion, we're going to call it an H for horizontal and V for vertical. Then your resulting, you simply take your X coordinate and you add your horizontal. And you take your Y coordinate and you add your vertical. Won't make a lot of sense until we actually do this, and then it'll make all kinds of sense. So right here, get ready to chant. It goes like this. I am saying exactly this right here. To slide, add to the left, add to the right. to slide, add to the left, add to the right, to slide, add to the left, add to the right. So translation, you're sliding, you're going to add something to the left and right. We're going to do this one together and then the one on the right on your own. So step 1, let's get our A coordinate. That is 4 and 3. Let's get our B coordinate. That is 7 and -1. And then our C coordinate is +2, -2. All right. It says we're going to translate it by going 6 units to the left. So technically we -6. And then 2 units down. And since it's down, it's also -2. So you can do this physically or algebraically. First, I'm going to show you algebraically. So for all of the x coordinates, you're simply going to -6, -6, -6. For all of your y coordinates, you're going to -2, -2, -2. Let's get those 3 new coordinates. So that's 4 -6 is -2, 3 -2, +1. Do you see where I'm going here? Okay, let's go ahead and plot these new points. That's called A prime, so A with a little tick mark there. All right, your resultant, you should have the exact same shape. It's just been translated or slid. So that was algebraic. Watch very carefully. I'm going to take A. Put your pencil at A. Pencil at A. Ready? We're going to go 6 units to the left. Let's just bunny hop it. Now go 2 units down. Oh, looky there. Same point. See what's going on here? Let's do B. 6 units to the left. 2 units down. So you can see, you can do it algebraically, to slide, add to the left, add to the right, or you can simply physically bunny hop the translation and regraph your points. Okay, take what you just learned and do this page. Pause the video. All right, students, welcome back. Let's check your work here. Take a look at your coordinates. And again, you can do it algebraically or you simply bunny hop. Let's do the B. We're going to go 4 units to the left. 1, 2, 3, 4. And then it says 5 units up. 1, 2, 3, 4, 5. There's your new coordinate, B prime. So once again, you could do it algebraically, -4 for all the x's, +5 for all the y's. Why was it plus? Because it was up. Check your work, folks. If you're correct, I should see a big star or smiley there. Ready? Let's do the next one. Reflection. We're going to reflect over the y-axis. So if I start with the XY, and I'm reflecting across the y-axis, okay, which means I'm going this way over the y-axis in this case. What changes is your x coordinate. So if I have positive x, positive y to flip over the y-axis, I opposite only the x coordinate. That's a reflection over the y-axis. Ready? The chant goes like this. To flip over the y, opposite the x. To flip over the y, opposite the x. To flip over the y, opposite the x. Let's do one together. Let's get our 3 coordinates here. It's the same one as beginning. You're going to start memorizing these. So that's a 4 and a 3. To flip over the y, all you do is opposite the x coordinate. So you take your x coordinate and you simply do the opposite. -4, only your x coordinate. Now, go ahead and plot those. It'll be very easy to see what happened here. Very easy. So we're at -4, +3. That's A prime. And you can see that your triangle has been reflected over the y-axis. So to flip over the y, opposite the x. You do this page, same coordinates from before. Alrighty, students, taking a look here. Again, if you check your work here, your should be flipped over the y-axis, an exact reflection, almost like a Valentine. If you were to fold this, they'd match exactly up. So to flip over the y, you opposite the x coordinate. Notice we just opposite the x coordinate. Now we're going to reflect over the x-axis. So now we're going to take it over that axis right there. So if I have x and y, it's exactly opposite. To flip over the x, you opposite the y coordinate. To flip over the x, you opposite the y. To flip over the x, you opposite the y. Let's get these coordinates here. I'm going to call that A. So A is going to be at -8, -8. B, -6 and -4. C. So we're going to flip over the x-axis, so we're going this way. It's kind of helpful just to kind of guesstimate where you're going. We're going over the x-axis. So now we opposite only the y coordinates. To flip over the x, you opposite the y. That's going to be called A prime. B prime. C prime. So your final results here. Is it has been reflected across the x-axis. To flip over the x, you opposite the y. This page you're going to do on your own, pause the video, and then restart. You're flipping over the x-axis. Okay, students, check your work. You should be looking like this. Again, all you did was opposite the y coordinates. And if it's 0, obviously you cannot opposite 0. So we have reflected over the x-axis. Okay, rotations. These are the tricky ones, so pay really close attention. Rotation means we're going to turn something around. We're going to do 90 degrees clockwise and 90 degrees counterclockwise. So what you do is you take your XY coordinate. Okay. To rotate 90 clockwise, you switch the order and you flip the sign going clockwise, which is just to the right. Okay. To rotate 90 clockwise, switch and flip to the right. This means go to the right because that's clockwise. To rotate 90 clockwise, switch and flip to the right. Let's do this one together. It's very important you do this in 2 distinct steps. Let me show you what I mean. Same points here we've been using. Okay. So to rotate 90 clockwise, again, it's a good idea just to get a guesstimate of where we're going. So just lightly draw a line. We're going to take this triangle and we're going to go clockwise about a quarter turn. So just do a light arrow so you shouldn't be able to visually tell which way we're going here. Now, rotate 90 clockwise, switch and flip to the right. So step 1, just switch the order. So if I have 4-3, make that 3-4. Just switch the order. Do nothing else. Now watch carefully. Now that's switch, and then we flip to the right. So we are going to draw a clockwise arrow and opposite the sign only on the right. So if that's a +4, that now becomes negative. Clockwise arrow, flip the sign. Clockwise arrow, flip the sign. Now I'm going to graph. So this first graph is 3, -4. So 3, -4, that is now my A prime. -1, -7. It's now my B prime. -2, -2. Whoops. Hang tight. I did that positive. Okay, so B is at -1, -7, so it's right there, a little bit bigger there. There we go. And then C is at -2, -2. Close it up. Now this is a little hard to see exactly how this is moved, so I'm going to give you a suggestion to double check. This is called rotating about the origin, which means, of course, around 0, 0. So choose any 2 sets of points, and we're going to draw lines to those points to see if they correctly align. So I'm going to just do the B set. Okay, ready? So from 0, 0, draw a straight line to B. From 0, 0 again goes to the B prime. If you can use a straight edge, it's helpful. Okay, now look carefully. Does this look like a right angle? Yes. Did we travel clockwise? Yes. That's how you know you are correct. Rotate 90 clockwise, switch and flip to the right. Okay, you do this page on your own. Pause the video and restart when you are done. Okay, switch and flip to the right. Let's check your coordinates here. I have 0 and -2 is my B prime. I have -3 and -2 is my N prime. And then X is -3 and +5. Excuse me, -3, -5. Which is right there. X prime, close it up. Once again, it's kind of hard to see whether or not this works, so you choose any two sets of points. I'm going to choose my N points and connect to the origin. So from the origin to N, from the origin to N, look, I've got myself a right angle and I went around clockwise. To rotate 90 counterclockwise, you switch and flip to the left, because that's counterclockwise. So we're going to do Y and X, but we're going to opposite on the left-hand side. Okay, same 3 points. Okay, so step 1 is, whoops, I switched my colors up on you. Okay, there's B and there's C. All right, step 1, you do this in 2 steps. So step 1, we're just going to switch. So if we have 4, 3, then we change it to 3, 4. -1, 7. -2, 2. Now, remember to estimate where we're going here. We're going to take this triangle. We're going counterclockwise, 90 degrees, a quarter turn. Now, we switch and flip to the left. So I draw a counterclockwise arrow, opposite on the left only, which means it's positive, it becomes negative. If it's negative, it becomes positive. Let's graph those 3 new points. That's A prime. It's B prime. A little off the graph, that's okay. C prime. Again, this is kind of hard to see if it worked or not, so we're going to choose any 2 sets of points. And just to match it up, I've been doing B, so I'm going to go ahead and do the C point. So from the origin, go to C. From the origin, go to C prime. Looky there, you have a right angle. And yes, you have traveled counterclockwise. So to rotate 90 counterclockwise, switch and flip to the left. You do this page on your own. Switch and flip to the left. Rotate 90 counterclockwise. Okay, students, I'm going to be halfway done here because I've switched it, and now we're going to flip the sign going left. If it's 0, you can't flip the sign. This one should have been +3. This also becomes +3. Let's check your 3 points. So we have 0, 2. Okay, that's B prime. Then we have +3, +2. That's going to be N prime. And then here we have +3, positive 5. I got my 0, 2 in the wrong place. Hang on. Your 0, 2 is right here. There's your B. Excuse me. 0, 2 has changed. There we go. B prime. There's N prime. And then we have positive 3, positive 5, which is up here. That's X prime. Close it up. Once again, it's hard to see if this worked or not, so we're going to draw connectors from the origin. I'm going to go to N, so from the origin to this N, from the origin to that N, we have a 90 degrees, and we went counterclockwise. The last one is a 180 rotation, also known as flipping over the origin, which is exactly the same thing. So 180 or flipping over the origin, just kind of sketch it. So that means to go across the 0, 0 or rotate 180. Guess what? Exactly the same thing. You take your X, Y, and you simply opposite both. So negative X, negative Y. Let's do this one together. So here we have 4, 3. 7, negative 1. 2, negative 2. And all you do is you opposite both. You don't switch the order, you just opposite both. So if I have positive 4 and positive 3, it's negative 4, negative 3. Exactly opposite. Negative 7, positive 1. Negative 2, positive 2. Plot those 3 points. You'll see really quick how this works. There's your A. There's your B prime, A prime, and C prime. How do you know if you're correct? Choose any 2 points, and let's check. Let's try our B's. Ready? Sweep the B's. Oh, looky there. That's 180. Guess what? Let's try another one. Ready? Now just go straight from C to C. Boom. You went right through the origin. So reflecting over the origin or rotating by 180 is the same thing. Alrighty, folks, you do these on your own. I'm not going to give you the answers. I expect to see them done in your preview notes, and I will check them myself.